Descriptive Epidemiology, Ecologic Studies. That's where we're going to start at today. So right now on the cover slide, you've got an image that shows you population level data. So this type of data can be used for ecologic studies or correlational studies. We've already kind of covered a lot of this stuff here. We've discussed case studies already. We've discussed cross-sectional studies, so we know the differences between a case report and a case series. We know case reports focus on individuals, case series focus on multiple people. We also covered cross-sectional studies, where we gather data like in a case series or case report. We gather data at the individual level, but these studies also gather far more information because we also potentially get information on not just the sick but also the healthy. And actually most people in a cross-sectional study are probably, in your healthy category. We sample from cross-sectional studies, so all this should be review. All right, now we know that we have some other designs. Correlational and ecologic study designs. I'm using those terms interchangeably, and that's fine for you all to do the same. Ecologic is not referring to like ecology. It's a term that's used to express like geographic areas. Ecos is the Greek word for the study of the home, and I'm guessing that's what this is referring to, is like it's not the individual level, but the places where people live. So correlational studies can compare two or more populations over the same period of time, and correlational or ecologic studies are often used for comparing different exposure characteristics or disease characteristics or frequencies in a population over time. We can compare the same population at different points in time, doing a time trend analysis. We can also focus on the population and compare different groups of people over the same periods of time. So this type of analysis could be used towards an ecologic analysis. These types of studies are often the simplest type of studies. You can gather population data right now. You could right now go online, get all the case information for every country in the world for COVID-19, all the mortality data for COVID-19, and then correlate that with something else about that country. The population density. You could look at among the cases, what's the case fatality rate, or at least the reported case fatality rate. How many people have got the disease? How many people have died from it? You could then generate a percent. It might range from 0.8% to maybe as high as 4% or 3%. I don't know. But with those case fatality rates, you could then plot those against the obesity values for the nation. Or you could plot those values against the smoking prevalence for the nation. Or you could look at US data and look at the cases and the percent smoking and do a correlation analysis and probably get it published. Usually ecologic data don't get published that often, but right now it's possible. So these are simple designs, usually looking at geographical differences in disease rates across regions, states, countries, provinces, townships, or whatever. When I say no formal data analysis occurs here, we're talking about like no formal like analytic odds ratios or risk ratios. You can still get those, but not at the individual level. The primary purpose of these is to describe and maybe generate some hypotheses, but not to actually make inferences about individuals. Multiple group studies can sometimes compare multiple things on the same like Y or same x-axis. Data for multiple group ecologic studies are often presented graphically, and people can measure the correlation coefficients or the percent of the variability explained. using an R-square. So this is linear regression. The statistical software gives them the R-square value. R-square means in this case in a linear regression that about 55% of the variability, and I guess this was, I don't know, income if I remember right. Not income, I can't remember what this was for. Yeah, I'm trying to remember. I don't remember what I pulled that data for. But anyways, if the percent of smoking goes up, this over here obviously went up too. So it may have been the number, if I remember right, actually it's the number of lung cancer cases per 100,000. So as smoking rates went up, the number of lung cancer cases per 100,000 I think is what that was that went up. There's time trend analyses. So right here in this previous one, it's like county level or state. This is state level data at the state level. But you can also look at state level data over time. You can look at community level over time. It's still not an individual measure. We're still looking at groups. And these methods are sometimes useful at the state level, seeing how you're doing with an intervention or something like that over time. So we've got our time trend ecologic studies here. You can see the obesity rate for the United States versus these other ones. Each one of these is its own kind of ecologic study, and you can throw them all together and have one big ecologic study. Here's more recent data than that one that expired in 2010-ish. You know, so we've kind of been flat on this. But I'm not going to spend much time on it. You see the advantages and disadvantages. You've heard them enough. So these are quick. They're not expensive. The data are often already out there and available. They're easy to explain. They're useful for generating hypotheses. Although they're easy to explain, though, they're also easy for people to draw conclusions about individuals. Again, we don't want to do that. Disadvantages. We don't have data that links the actual exposure to the disease in the individual. It's harder to control for confounding variables at the individual level. We can't test a hypothesis like, is smoking related to lung cancer? Like, you can see it is it related at the county level, but is it causing it at the individual level? You wouldn't be able to do that with this kind of study design. So you can't claim causality from your results. And these situations where the relationship between an exposure and a disease at the ecologic level doesn't hold true at the individual level. So if there are situations where something is not true at the individual level, but is true at the population level, or it's one thing at the population level and the opposite at the individual level, we call that the ecologic fallacy. So just some simple review questions. I'll have some quiz questions that will include some of this stuff. So our next video we're going to get into are analytical epidemiological study designs. We're going to only go into the case control design for this section. Next section we'll cover cohort study designs. And I will stop this here.